مرحبا. Okay, so we've seen what is a function. Remember that we have a function. Okay, so remember we have a function f from a to b. A is called the domain, b is called the codomain, and the symbol f is the name of the function f. Remember what was the function? It was an assignment where for every element in A we assign exactly one element in B. See here. Okay, this is a function, right? Because this element is assigned one element here, this element is assigned this element here. It is the same, but it's only one. Okay, so and this element is assigned this element. So every element in the domain has one and only one element in the codomain. Okay, maybe I need to tell you an example of a diagram which is not a function. So when an assignment is not a function, so if this element is assigned to this element and this element is assigned two images, and okay, so this is not a function. Okay, so this is not a function because this element has two images. Okay, another reason, for example, if this is not a function because this element is not assigned an image. Remember, a function has to assign an image to every element in the domain. Okay, so now let us talk about one special property of a function which is called injectivity. We want to define what it means for a function is injective. Again, let me motivate the idea of injectivity by a diagram. So imagine we have a function f from a to b and we have elements here and elements here. Okay, so say this has this image, this has this image, this has this image, and say this has this image, and maybe B has more elements. Okay, so now if you look at this picture, what do you see? That look at the elements of A, all of them are assigned images, but another observation is that no two elements in A have the same image in B, right? So look, these two have different images, this one and this one. These two have different images as well. This one and this one have different images. Okay, this property is called this is called injective function, or another name is 1-to-1 function. Okay, so now let's define it. Let's define what is, so definition: a function f from a set A to a set B is called injective if and only if for all A1 and A2 in the domain, if A1 is not equal to A2, so if we choose two different elements, then their images, the image of A1 is different from the image of A2. Okay, so this is the idea of injectivity, is that any two different elements in the domain must have different images in the codomain. Okay, let's write this in logic, in predicate logic. So for all x1, for all x2, if x1 is not equal to x2, then the image of x1 is not equal to the image of x2, where the domain of the variables domain of the variables x1 and x2 is what? Is the domain of the function. Okay, so here x1 and x2 comes from the domain of the function a in this example. Okay, now let's write this using the so f is injective if and only if. Let's write the contrapositive of this. If and only if for every x1, for every x2 in the domain of the function, if these two elements have the same image, then these two elements must be equal to each other. Okay, so this is by contrapositive. So these two statements define injectivity. Either any two elements in the domain have different images in the codomain, or if you have two elements in the domain and it happens that they have the same image, then they must be the same element. Okay, so this means that this is A and this is B, and suppose you have two elements x1, x2, and they happen to have the same image, then actually these two elements must be the same element, must be equal to each other. Okay, so okay, now let's have an example. This function, okay, so this function is not injective. Let's have an example of a function which is not injective. So imagine this have this image, and this have this image, and this has the same image as the previous one. So this is not injective because look at these two elements, they are different but they have the same element. Okay, so this is an example of a function which is not injective. Now let me say this observation, that f is injective means that every element in the range of the function, in the range, has exactly one pre-image. Has exactly one pre-image. Okay, so look here. Look here. What is the range? Let me use the red color. The range is the images, the red ones. Okay, and see that every element in the range, the red ones, has exactly one pre-image in A, in the domain. However, in the example where we have a function which is not injective, look at this element. This is the range, but look at this element. It has two pre-images in the domain. Okay. Now, okay, you want. Okay. Maybe I want to say also that f injective, let me say another way to say what it means to be injective, means that no two different elements in the domain are assigned by the function, are assigned the same image, in the codomain. Okay, so this is another way to see what does it mean for a function to be injective. So here we have two different elements which are assigned the same image, so it's not injective. Okay, now let's let me give you another example, say the blue color. So here we have the domain has A, B, C, D, and in the codomain, we have 1, 2, 3, 4, and 5, and the image of A is 4, the image of B is 5, the image of C is 1, and the image of D is 3. So this is injective function, is an injective function. You see why, right? Because look at the elements here, A and B have different images, 5 and 4. B and C have different images, 1 and 5 as well. Okay, D and C have different images, and so on. Now here is a question for you. Is f defined from z to z given by f of n is equal to n squared? Is it injective? Now what does it mean? How to check if a function is injective? You need to check that whenever you choose two elements here in z and they are different, their images are different. So is this function injective? The answer is no. Why? Because there are two elements different in the domain, but they have the same image in the codomain. So for example, f of minus 2 is equal to f of 2, which is equal to 4, but 2 is not equal to negative 2. So we managed to find two elements in the domain, 2 and negative 2, where they have the same image. Okay, now what happens if we restrict this to the natural numbers? What happens? Okay, so let's see. So example, show that it will become injective. Show that the function g from the natural numbers to the natural numbers where g of n is the square of n again is show that this function is injective. So let's see. Again, what do we need to prove? Do we need to prove that, okay, we will show that for every m, for every n natural numbers, if they are different, then their images are different. So we want to prove this universal statement. So how do we prove this? Choose arbitrary elements. So let m and n be in the domain, and suppose that m is not equal to n. And now we want to show that their images are not equal. Okay, so here is the picture. Here's n, and here's the domain n. We choose two different elements, and we want to show that their images must be different as well. Okay, so suppose m is not equal to n. So what do we have now? We have two natural numbers. Remember, what are natural numbers? They are the numbers starting with 0, 1, 2, 3, 4, 5, 6, and so on. So imagine we have two of these numbers, m and n, and they are not equal. So since they are not equal, we have two choices left. Either m is less than n, or n is strictly less than m without loss of generality. So we write without loss of generality. Suppose that m is strictly less than n. Okay, here we have two cases. Case 1, that m is 0. Now if m is 0, then what happens? This means that n is bigger than 0. Now square both sides, then 0 is strictly less than n squared, and this 0 is g of 0, right? Okay, this is g of 0 is strictly less than, what is n squared? It's g of n. Okay, so in this case we proved that, but m is 0, so this means that g of m is strictly less than g of n. Okay, and this means since g of m is strictly less, this means that g of m, okay, this means that g of m is not equal to g of n. Okay, so what did we show? That if m is not equal to n, then the image are not equal. This is when m is 0. Now case 2, look, m is not 0, which means that m is strictly bigger than 0 and strictly less than n. So now look at this equation. M is strictly less than n. So we can multiply both sides of this inequality by m to get that m squared is less than n squared. And notice that m is positive, so we preserve the inequality. Also, if we multiply this inequality by n, this is my n times m. Let me correct it here. Okay, if we multiply both sides of this by m, then this is m squared and this is m times n. Now if we multiply the same inequality by n, then this will be m times n is less than n squared. Okay, so I'm multiplying this inequality once by m and once by n. So we get these two inequality, and this means that m squared is strictly less than m times n, and m times n is strictly less than n squared. So this implies that m squared is strictly less than n squared, right? But what is m squared? It is the image of m. And what is n squared? The image of n. And since the image of m is strictly less than the image of n, then in particular they are not equal. Okay. So in both cases we prove that if m is not equal to n, then the image of m is not equal to n, and therefore this shows that for every n, if m is not equal to n, then the image of m is not equal to the image of n. And this is exactly the definition of injectivity. So i.e. G is injective. So is an injective function. And sometimes when G, let me say this comment, when G is injective, injective is an adjective. So when a function is injective, we say also that G is an injection, where injection is a noun. Okay, so let's stop here.